Okay, so in the previous video, I gave you one example of oxidation and reduction involving iron and oxygen forming rust or iron 3 oxide. That was really clear oxidation. So now I want to give you an example for you to try based on these different rules for oxidation and reduction. So this is a really classic, really important example in biology. It's happening in your cells all the time. C6H12O6 plus 6O2 yields 6CO2 plus 6H2O. So for this example, this is a really great example to practice oxidation and reduction, and there's a couple different ways for you to look at it. So what we want is to find out what is oxidized. What is oxidized above? Oxidized. What is oxidized? What is reduced? What is the oxidizing agent? What is the reducing agent? So go ahead, pause the video, answer these 4 questions, and then come back. Okay, so let's go ahead. And first, you got to figure out what's matching in the product and the reactant. Okay, so we've got carbon over here, and we've got carbon over here. These carbons have to be responsible for those carbons because that's the only place that carbon's coming from, so therefore that's where it's going. Okay, and so if that's going there, then this oxygen must be becoming water. So let's go ahead and start with the oxygen because there's only a couple things going on there. What we see here is oxygen, O2, is becoming H2O. This is a gain of hydrogen, which means it's also gaining electrons, which means it is reduction. So that's our increase in hydrogens and electrons means that this is being reduced. Oxygen is being reduced. When oxygen is being reduced, it is the oxidizing agent. The agent is causing oxidation. Oxygen causes oxidation. So the oxidizing agent is O2. So whatever is being reduced is paired with the oxidizing agent. Okay, for the next one, let's do beautiful blue. Carbon C6H12O6 is going to 6CO2. This has hydrogens here. It does not have hydrogens here, so it has lost hydrogens. So we're seeing a decrease in hydrogens, decrease in the number of H's. We are also seeing, so that also means decrease in number of electrons. We are also seeing, so here the carbon to oxygen ratio is 1:1. Here the carbon to oxygen ratio is 1:2. This is also an increase in oxygen if you break down the molecule. So there's a couple different ways you can think about it that way. And ditto here for the oxygen going to water, it's gaining hydrogens. It's very visible, but if you look, like, it's also losing oxygens there because this whole molecule was oxygen. Over here now it's oxygen diluted with other atoms, so that's really losing oxygens. So here we're losing hydrogens, gaining oxygens in the sugar, or glucose over here, so that means that this is being oxidized. C6H12O6 is being oxidized, and whatever is oxidized is the reducing agent, C6H12O6. As you can see, the answers to both of these questions, reduced and oxidized, it's always going to be a reactant, reducing agent, oxidizing agent, also reactants. All of the answers are on the left-hand side, the reactant side of the equations. So if this was a good example that kind of helps you understand what's going on in these redox reactions.